10.2, simplifying radical expressions. So our objectives for this lesson are we want to be able to simplify radicals when we multiply them together, and we want to simplify radicals when we divide them together. We simplified in the past, we're going to go over that again, but our main objective, we want to know how to simplify radicals by multiplying them, and simplify radicals by dividing them. Radical expressions, this is an expression that contains a radical. So if I gave you radical 36, that's a radical expression. Actually, it turns into just 6, so maybe not. Radical 5, that's a radical expression. 3 rad 5 is a radical expression. That's all it is. So now it contains a radical sign. Here's some general rules about radicals. When we simplify radicals, there's some general rules we follow. So no radical can have perfect square factors than 1. All that means is you're not going to leave it radical 36. You have to break it down. You can't leave it radical 8. Because you can actually break down radical 8. We're going to talk about that. You're going to get 2 rad 2. So that's all that means. You want to simplify if you can. No fractions, so they don't want you to leave it like this. They want you to break it up. Both are fine, honestly. No radicals for the denominator. So this is actually a contested one. With a little star. Ugly star there. In AP Calc and IB Math SL, they don't care about radical denominators. But in general, you're not supposed to have radical denominators. So we're going to talk about in this class how to get rid of a radical denominator. So generally, this is not going to be, we don't want this. We're going to want something with a radical on top. But we'll talk about that because again, that's a gray area now. Anyway, our first rule. Actually, it's more of a property than a rule, but the product property of square roots. So all this means is this. It's that if you have a radical of some number like 45, you could break it up with the two factors of it. So 45, 5 times 9. That, and then you could break it up. Radical 5 times radical 9. In this case, radical 9 is 3, so I get the same thing as 3 rad 5. It also works the other way. If I have rad 3 times rad 7, I could bring them together. And then simplify it, radical 21. So it works both ways. That's the product property of square roots. You can multiply 2 square roots and get a square root, and you can break up a square root, 2 smaller square roots. And that's what we're going to use to simplify these guys. So again, most of you guys probably done this before, but we're going to talk about it. We want to break down rad 8. If you remember our first rule, no radicals have perfect square factors other than 1. So there's a perfect square in there. We don't want to leave, we want to leave everything in there that it's not a square. You want no 4s, no 9s in there. Everything that cannot be broken down as a square. So we want to simplify this. Now most people learn how to do this using the prime factor tree. I actually don't use them. I will show you the thing I do, but here's a trick to doing prime factor trees so you don't get confused. Always start with the small number. Always start with small numbers. I mean like the smallest numbers. Like, what's the smallest thing that breaks down into 80? I would say 2. So it's 2 and 40. And then it's 2 and 20. And then 2 and 10. And then 2 and 5. Right? You broke that down. It's gone. That's gone. That's gone. That's gone. You want pairs. We're doing square roots. You want pairs of numbers. So here's a pair. And here's a pair. Pairs come out. So like what I mean by that is you have a radical. That 5 had no dance partner, so it followed by himself, so that stays in here. That pair came out and made a 2. This pair came out and made a 2. What happens with these guys? They get multiplied. You always multiply the numbers outside, so you get 4 rad 2. And that's how you break down rad 80. That's the way I do it. Some people just break it down. Like if you're good with your numbers, you totally could just do this and go, okay, oh, that's 16 and 5, and then square root of 16 is 4. So 4 rad 5. I really can't do it most of the time. I just go slow. And actually, the way I really do these is I use something called upside down division that was taught to me, which is what I do this. I write it upside down. I start small like I talked about. I'm going to divide that by something small like 2. And I get 40. And divide that by something small like 2. And I get 20. Something small 2. And I get 10. And then 2. And I get 5. I get my pairs here. 2 and 2 is 4. 4 rad 5. So that's the way I actually do it. I don't care which way you do it. If I did the factor tree, I'd just use small numbers like I do here. Or if you're pro, you skip ahead. So we're going to practice with a couple more here. I'll break down 54. I'm going to do what most people do. I'm going to do tree. I'm going to do it my way though. 2, so that goes into there. 54 divided by 2 is 27. I'm going to break that down. That's 3 and 9. And then again, you could break down 9. I know square root of 9 is 3, so I could go with that, but just for the sake, I'm going to break it down so you can see it. And then what happens here is, you do the pairs. I have a pair of 3s. That comes on the outside. On the inside, I'm left with 2 and 3. You multiply whatever on the inside or whatever's on the outside, so you get 3 rad 6. And that's all you can do. You cannot break down 6, right? 6 is 2 and 3, but no primes. So there you go. I'm going to do 180. So again, most people here probably go like 18 and 10. Whatever. I do it my way. 2 and I go 90. I go 2 and 45. Oh, 5 goes in there and 9. And then again, I know what 9 is, but I'm going to put 3 and 3 this way so you can see it. These are all factored. And I get that. Look for the pairs. So I have a pair of 2s and a pair of 3s. So again, that makes a 2 on the outside. That makes a 3 on the outside. And radical 5 is left inside. So I get 6 rad 5. And that's prime factorization. And again, if you want, you always do upside down division. It's the same thing. 2 and 90. I go for here, I'll probably go 3 and 30. Just thinking out loud. Then 3 and 10. And then 2 and 5. Right? It doesn't really matter. You got your pair of 3s, your pair of 2s, 6 rad 5. Exact same answer. So any way you want to do it. Now it's about how you multiply square roots. So the key thing about multiplying square roots is this: if there's 2 things on the inside being multiplied, inside the radical, you just multiply them. So I get 2 times 14. And you can get radical 28. But I want you to simplify that. So you actually have to now go work backwards and break it down. Because actually I don't want rad 28. I want a simplified version like we had up here. So if you hopefully you notice that that's kind of dumb for me to do this. If I'm gonna break it down, why don't you just leave it with this? Let's break this down. 14 is 2 and 7. So I have 2 times 2 times 7. Hey, there's a pair. So that's just 2 rad 7. If you don't like that, just do it the other way, right? Rad 28. You could also just do what we just did. That's 2 and 14. 2 and 7. Pair of 2, so 2 rad 7. Again, whichever way you like. Right, so we're going to multiply these here. But again, I want to simplify it. So when you multiply these together, you're going to get rad 5 times 10. I say just leave it like that. So this is going to become rad 5. Break down 10. That's 2 times 5. Hey, there's a pair of 5s. They come out. So it's 5 rad 2. Remember, the pairs come out. The singles stay. Again, if you don't like that, just multiply 5 and 10. You get rad 50. And you can work your way down from there. Whichever works for you. 6 times 8. Last one of these we're going to do. So I'm going to get 6 times 8. And again, instead of multiplying together, just break it down here. That's 2 times 3. That's 2 times 4. You can break down some more, but there's lots of things happening here. First, I have a pair of 2s. So 2 comes out. Second, I know what the square root of 4 is. That's also 2. So another 2 comes out. We're left with 3 inside. So 4 rad 3. Again, you're not happy with that? Just multiply them together. You get radical 48. Do a little 2 times 24, and then 2 times 12, and then 2 times 6, and then 2 times 3. You got 2 pairs of 2, which is 4, and then you have a 3. Right, whichever way works. Next step, we're going to kick it up a notch. What happens when we add radicals, we add variables into the mix? So let's talk about simplifying square roots of variables. So the first thing I want you to do, we're going to use that property to split these up. So it's going to be like radical 100 times radical y to the 8th. Hopefully we all know radical 100 is just 10. And you have to deal with this guy. So one way you can deal with this is just do this. It's a long way. Just rewrite y 8 times. That's what's going on. 6, 7, 8. Right, so there's 8 y's. And remember, the way radical works is that you want pairs. So 1, 2, 3, 4. So you get y to the 4th. So 10 y to the 4th. That's what we're doing. Like, okay, square roots, pairs, blah, blah, blah. A short way of doing that, though, a short way of figuring out, oh, how they're a pair of 2's, is to just divide. You have y8, and just divide it by the number of pairs you want. Right? We want pairs of 2 because we're doing square root. So I'm going to get y to the 4th. And there you go. That's all dividing is. When you want, I want them pairs of 2's, so divide by 2. You want pairs of 3, divide by 3. That's all dividing is. So we're going to use that property to do that. So look at this one real quick. So I'm going to break it down to radical 49, and then square root of u8 v12. Radical 49 is just 7. Easy. So here we're going to do this. We're just going to divide, right? Oh, I want square root means pairs of 2, so I'm going to get u8. I'm going to divide that power by 2. And I'm going to get u4. My v here, I have 12. If you divide 12 by 2, we just get 6. And that's my answer. One more time, make sure we got this, and then we'll do it when it's a little bit harder. Break this one down, radical 64 times y8 z6. Radical 64 is 8. 8 divided by 2, because that's what square root is. It's really just a 2. You get y4. 6 divided by 2 is z3. So let's get a little tougher. What happens when it doesn't divide evenly? Right, so we're going to do the same thing. We're going to break it up. Right at 12. I'm going to break these up separately because it's a little different. So now first 12, that's not square root right now, so we got to break that down. I always like to start small. 2 and 6, 2 and 3. I have a pair of 2's, so that comes out. I have a radical left hand side with 3. C6 I know, because I'm going to divide it by 2. So 6 divided by 2 is just 3. So I have C3 on the outside. Now what do I do over here with the D3? That doesn't divide evenly. So again, one way you can always do is just write down D3 times. You're looking for pairs of 2. So there's one pair of 2's, of D's, and then there's one left over. So that way it works. How does that work when we divide? Well, it's 3 divided by 2. 1 times 1. Subtract 1. 1 remainder 1. So we have 1 on the outside, the remainder on the inside. That's the way it works. So we're going to try it here. So I got to break down 90. I'm going to break down x3. I'll break down y4. And we're going to break down z5. So first 90. I like to start small. 3 and 30. 3 and 10. 2 and 5. I have a pair of 3's. So that goes on the outside of the pair. 2 and 5 can't do anything. So you can have a 2 and 5 on the inside, or just 10 if you multiply them. Now all we're going to do here, since they're powers, we're just going to divide by 2. So 3 divided by 2, 1 remainder 1. So we're going to have 1 on the outside, 1x on the outside, sorry, and 1x on the inside. 4 divided by 2 is 2, remainder 0 if you care. So there's 2 y's on the outside. And then finally z, 5 divided by 2. 2 times 2 is 4, minus 1, remainder 1. 2 remainder 1. It's an ugly 2. It's a 2 though. There we kind of go. 2 remainder 1. So we're going to have 2 z's on the outside. Oh, I have no space. And one z on the inside. So it looks like this. That looked ugly. Z squared, square root of 10xy. xz, sorry. There you go. So that's how you do variables. You just divide them by 2 with square root. If it's an odd number, then it means you have a remainder of 1, so that the remainder stays inside. Otherwise, it's divided by 2. Now let's talk about prime factorization. As we mentioned earlier, when we do radicals, math people generally don't like it to have radicals, fractions inside a radical, so you have to break it up. But then we also don't like having radicals in the denominator, so to simplify that. And the way we do that is we multiply the top and bottom by the common denominator of the bottom, radical 2. We rationalize, we call this. Which means you just multiply both top and bottom by the denominator. On top you get rad 3 times rad 2, which is rad 6. On bottom you get rad 2 times rad 2, which is rad 4. So I get rad 6. Radical 4 I know is 2. And we're radical. And you cannot simplify this. Don't give me rad 3. That's not what this is. When it's something inside a radical, it's stuck unless you have another radical. Otherwise, radicals and non-radicals do not come out to play together. So let's look at this first one here. It's like a little practice SAT problem. I want to know what this is equivalent to. So I have radical 35 over 15. So first, let's try to reduce it. I could divide them both by 5. So 35 divided by 5 is 7. And 5 divided by 5 is 3. 15 divided by 5 is 3. Then I can split it. Rad 7 over rad 3. We don't like radicals in the denominator, so we're going to rationalize this. All that means is divide both top and bottom by the denominator. On top you get rad 21. On bottom you get rad 9, which is the same thing as saying 3. And again, you cannot reduce this. That's a radical, that's not a radical, they don't mess around. So right there. Try with the next one. So this one I can't do, so I'm going to split it first. Radical 27 over radical m5. Now before I start, let's reduce this. So radical 27, let's break it down. 3 and 9, 3 and 3. Have a pair. So that's going to be 3 on the outside, and then a single 3 on the inside. M5, we just talked about this, right? You get the power and you divide it by 2. 5 divided by 2 is 2 remainder 1. So you have 2 m's on the outside and 1 m on the inside. The remainder is on the inside. So it's like this. If I have a radical in the denominator again, right? They don't want this. So we're going to rationalize it. Multiply top and bottom by this is the thing with the radical in it. That's it. Multiply top and bottom by the radical. Now, how does this work? Only the radical gets multiplied by the radical. So I'm going to have 3 on the outside. And then 3 and m could be multiplied because they're both radicals. Same thing down here. I have m squared. Radical n times radical n is m squared all again. That just cancels out and you get 3 over 3m. M squared times m cubed. That's how that one works. Next up, more difficult fractions. Before we start this, let's talk about the vocab. Conjugate. Some we're going to hear over the next couple math classes. That is when you have a binomial. So something like, right, something with two terms like 3 plus rad 2. The conjugate's just where you change the middle sign. So 3 minus rad 2. Now what's the benefit of this? Just like we learned before, here's a famous conjugate. A plus B and its conjugate, A minus B. And what's the benefit of conjugates? When you multiply these together, you get the difference of two squares. So you're going to get A squared minus B squared. Same thing happens here. If you happen to multiply these two conjugates together, you're going to get 3 squared minus rad 2 squared, also known as 3 minus 2. So that's why we like conjugates, because when you multiply them together, you get a difference of two squares. You get squares on both sides, and we're going to use that to simplify these radicals. See, something like this. If we try our old rule, and we're like, let's multiply by let's rationalize this. Multiply by rad 2 over rad 2. Look what happens. On top, 3 rad 2. On the bottom, you got to distribute all the way. You get 5 rad 2 plus rad 4, which is just 2. So I get 3 rad 2 over 5 rad 2 plus 2. I still have a radical on the bottom. It's not going to work. So what we do here when we have a binomial on the bottom is we do the conjugate. So you have 3 over 5 plus rad 2. We're going to multiply by the conjugate, which is going to be, all you're going to do is change the middle sign. So 5 minus rad 2. 5 minus rad 2. On top you distribute, so you're going to get 15 minus, now remember the way it multiplies, that's a radical, that's not, so it's just 3 in front. 3 rad 2. Right, it does not go inside the radical, unless it's a radical. On the bottom, you can multiply it out, 5 times 5, 5 rad 2, blah blah blah, or it's a difference of 2 squares. 5 squared minus rad 2 squared, also known as 25 minus 2. These cancel. So you get 15 minus 3 rad 2 over 23. And there you go. Rationalize. So do it one more time so we know the idea. So this one right here, right? Oh, it's binomial on the bottom. We're going to multiply by the conjugate. So multiply both top and bottom by the same thing. Conjugate in this case is 3 plus rad 7. We're going to multiply the 7 by both of them. You're going to get 21. Again, 7 times 7 is not 49 because that's outside the radical and that's inside the radical. So you just get 7 rad 7. On bottom, again, if you want, you can actually just multiply it. You can get 9 plus 3 rad 7 minus 3 rad 7 minus radical 49. These cancel. You get 9 minus radical 49 is 7. So you just get 2. Or, difference of 2 squares. 3 squared minus 7 squared. Sorry, minus rad 7 squared. So you get 9 minus 7. 2. And that's how you rationalize when it's a binomial on the bottom. Last thing we're doing, load application problem. Precision. When finding a fire, the velocity v of a water being pumped into the air is modeled by the function this. Where h represents the maximum height of water, you always want to know what each variable means. So h is max height of water, it's going to be very important. V is velocity, super important. And g represents the acceleration due to gravity. Oh, little physics. So g is this guy. A. Solve the function for h. So they want me to get h by itself. So we're trying to get this guy by itself right there. So first thing we do is get rid of this radical. Let's opposite square root is square. Let's square both sides. So you get v squared equals 2hg. Now again, you want the h by itself, so let's get rid of the 2 and the g. They're being multiplied right now. You just do the opposite. 2g divided by 2g. Those go away. And you get h equals v squared over 2g. So that's my function, solve for h. So h by itself. B, our last thing we're doing today. The hollow vial fire department needs a pump that will propel water 80 feet into the air. So again, where have I seen that before? Where h represents the max height of water. So that's probably going to be my h, 80 feet into the air. Will it pump advertise to project water with a velocity of 70 feet, that's my v, per second meet their needs? Explain. So we want to see if we actually get, if we want to get water 80 feet. So that's what we want. We're actually not going to plug it in. We want to see if we can get that. Can we get 80 feet of water? Let's plug in our velocity into this formula. G is always 32 feet per second, so let's plug it in and see what we get. So h is going to be velocity, 70, squared over 2 times the gravity, 32. We're going to plug that into a calculator because it's an application where I'm going to use a calculator. And here's my calculator. So we're going to do parentheses 70 squared divided by 2 times 32. Okay, so 2 times 32 is a little tough. Parentheses 2 times 32. You gotta make sure you do it like that. If you just put it, if you put the way I wrote it here, I'm just gonna, your calculator's only gonna do 70 divided by 2, and not the other way around. Like if I did this, and I was just like, oh, divide by 2 times 32. The calculator thinks that you're doing this first, and then you're multiplying by 32. So it will not give the right answer. Way too big. Right, so do it correctly. Or, here's a little trick. Alpha of y equals lets you put in a fraction. So now I can put, look at that cube fraction. So you put 70, I'm not sure if cube was that operator word, but the one I went with. 70 squared over 2 times 32. Right, looks just like the way I want it. And then I gave a fraction. That's not what I wanted. It usually works better than that. I had to change my settings. Anyway, I got 76.562. So about 76.52. Now I wanted to go all the way to 80, so this does not reach it. So no, it will not reach 80 feet. So there you go. We are done.